Hi everyone, we are from Group 5 and we're going to present our slide with the title of AI-driven smart aeration optimization system, also known as Aerofish AI. This is our team, which consists of 5 members. Our slide consists of introduction, problem statement and objective, overview of design, product details description, budgets, conclusion, and lastly references.
Salam sejahtera. I will begin with a brief introduction on aquaculture aeration. Aeration is a critical operation in aquaculture to maintain sufficient dissolved oxygen levels for fish and shrimp survival. In many farms, aerators are operated manually or on fixed schedules without considering actual oxygen demand. To prevent oxygen depletion, especially at night, aerators are often run continuously. However, this practice results in high electricity consumptions, increased operational costs, and sometimes inefficient oxygen distribution.
Next, I represent problem statement and the objective. First problem is erosion are often operated continuously, especially at night, causing high electricity costs even when oxygen demand is low. Secondly, oxygen management is inefficient because aeration follow fixed schedule, not really pond conditions. In addition, sudden drop in dissolved oxygen are not detected earlier, which may lead to fish stress or mortality. Lastly, oxygen demand is complex as it depends on temperature, biomass, and the feeding activities. To address this issue, several objectives are proposed. The system aims to develop an AI-based smart aeration system with real-time control to optimize dissolved oxygen when reducing energy use and prevent fish stress and mass mortality, and to provide earlier alert for low oxygen risks.
Now, I will explain the overview of the system design. First, a camera placed above or inside the pond continuously monitors fish behavior such as swimming speed, fish density, and surfacing activity. These behaviors are important indicators of oxygen demand. At the same time, water quality sensors, including dissolved oxygen and temperature sensors, collect real-time environmental data from the pond. All the collected data is then transmitted through an IoT network to a cloud or edge-based AI processor. Next, the AI model analyzes the fish behavior together with sensor data to estimate the real-time oxygen demand of the fish. The system then compares the estimated oxygen demand with the current dissolved oxygen level. Based on this analysis, a control algorithm automatically adjusts the aerator speed and airflow intensity. And finally, all important information such as oxygen levels, fish activity, aerator status, and warning alerts are displayed on a dashboard that can be accessed by farmers using a mobile phone or computer.
Hello everyone, my name is Emily Eliclaris and I will now explain the product detail description. Aerofish AI is an advanced smart aeration system that uses artificial intelligence to scan fish behavior and estimate their real-time oxygen demand. Instead of relying only on dissolved oxygen sensors, the system analyzes fish swimming speed, crowding, surfacing frequency, and activity level using a camera and computer vision model. The AI then adjusts aeration intensity dynamically to match the actual oxygen needs of the fish, ensuring sufficient oxygen supply while minimizing energy waste.
Next, I will explain some of the main components used in this system. First, the microcontroller ESP32 collects data from the sensor and transmits it wirelessly for system control. Next, the dissolved oxygen sensor measures the oxygen level in the water, allowing the system to determine when the aerator should be turned on or off. The temperature sensor monitors water temperature to help maintain optimal conditions for fish health and oxygen efficiency. Next, the turbidity sensor measures water clarity to support water quality monitoring and smarter aeration decisions. Next component is variable speed aeration motor They control the oxygen supply by adjusting the aeration speed based on sensor data. Next component is the motor driver. Regulate the speed of the aerator motor according to the commands from ESP32. Next, Wi-Fi and LoRa communication module transmit sensor data and system status wirelessly to the user or cloud platform. Next component is the cloud-based AI platform, where analyze sensor data and support intelligent decision-making for aeration control. And lastly, the mobile or web monitoring application display real-time water quality data and allows users to monitor and control the aeration systems remotely.
Next, this slide explains the material selection used in the Aerofish AI system. Firstly, the electric components are placed in a waterproof ABS or PVC casing. This protects the electrons from water, humidity, and the dust. Next, the aeration use a casted material frame. This material is strong and corrosion resistant, allowing the aeration to operate safely in the pond condition. Third, insulated electrical wiring is used to safely transmit power and control signals and to prevent electrical leakage or short circuits. Lastly, a weather-resistant control box houses the control unit and motor drive. This protects the system from rain, heat, and the outdoor damage.
Now, let's moving on to the mechanism. First, the camera will continuously monitor fish behavior such as swimming speed, clustering, and surface gasping. These behavioral indicators are processed by an AI computer vision model trained to estimate the fish oxygen demand. Simultaneously, dissolved oxygen and temperature sensor will provide supporting environmental data. After that, the AI model will combine all this behavioral and sensor data to calculate the required aeration level. The control unit then automatically either increase or decrease the aerator speed to satisfy fish oxygen needs in real time. And lastly, alerts will be sent to the farmer if abnormal oxygen demand or stress behavior is detected. Now proceed to the product drawing design. So this is our product design that we ask AI to sketch the drawing based on our description. So first we have adjustable HD camera with AI processing unit. This camera will capture the fish behavior and send the data to the cloud-based monitoring control panel. After the data being processed, it will give signal to the submersible aeration motor to either increase or decrease the underwater diffuser.
Now I will talk about the budget estimation. This table shows the estimated cost of each component used in our system. First, the ESP32 microcontroller. It costs RM40. The dissolved oxygen sensor is RM220. The temperature sensor costs RM40, while the turbidity sensor is RM90. The variable speed aerator motor is RM200 and the relay or motor driver costs RM120. For communication, the Wi-Fi or LoRa module is RM80, the cloud-based AI platform costs RM80 and the mobile or web monitoring application is RM50. The control box and wiring costs RM20. Overall, the total estimated cost of the system is RM940.
To conclude, Aerofish AI shows how artificial intelligence and IoT can be applied to improve aeration management in aquaculture. By adjusting aeration based on real-time fish behavior and water quality data, the system helps reduce energy consumption while maintaining sufficient oxygen levels. This approach can prevent fish stress and reduce the risk of sudden fish mortality. Overall, Aerofish AI supports smarter, more efficient, and more sustainable aquaculture practices.
This is our references that we use in our mini project. And that's all from us. Thank you.